Chemistry is the study of matter. That's fundamentally what it is. And all of matter is basically a blend of elements, compounds, and mixtures. Therefore, if we're going to start learning chemistry, it's pretty important that we understand these ideas. So let's start with some matter, some extremely simple matter, a single atom of hydrogen, which I'm going to represent here by simply a white blob. Hydrogen is a very simple element. It is located right there on the periodic table. It consists only of a proton and an electron, and it's the most abundant element in the universe. All that is not really what we're talking about here. We're just saying it's an element. Here's a picture of a collection of hydrogen atoms, which we call pure hydrogen gas. You'll notice that the atoms are in pairs. It's pretty hard to miss that, but I'm going to ask you to just kind of ignore that for a moment. While it is true, and it is a pretty important fact about hydrogen, I'm not going to explain why or how that happens until much farther down the road in this class. So for the moment, I just want you to think of it as a collection of hydrogen atoms, a collection of the element hydrogen. Here's what hydrogen does. It is highly explosive. This is a depiction of the explosion of the Hindenburg airship, which was a giant luxury cruiser blimp that exploded over New Jersey in 1937. It was filled with hydrogen because hydrogen floats, but unfortunately, hydrogen also explodes, and it was a tragic event. Here's another element, oxygen. Oxygen is one that you're very familiar with. It is located here on the periodic table, and when I say oxygen, I would hope that your immediate thought would be, oh, that's the stuff we breathe. Here's a collection of hydrogen atoms, again in pairs, but what I want you to think of is just, oh, that is a collection of the element oxygen. Here's what oxygen does. Also burns, but in a much more friendly way. This is just a sort of normal, typical run-of-the-mill fire. And in almost all cases, anytime anything burns, it's because that substance is having a reaction with oxygen. Oxygen is required for almost all fire, and I would venture to say that all fire that you have ever seen has been something reacting with oxygen to create fire. So we've got two elements, the element hydrogen, the element oxygen. If we react them together, we make water, a compound. You can tell it's a compound because there's more than one type of atom in this picture. This is one molecule of water, and this is another molecule of water, and so forth. Now, I dare say we know a lot about water, and here's what water does. It doesn't explode, it doesn't burn. It's completely different than pure hydrogen and pure oxygen because that reaction that happened and that formation of those molecules meant that the whole situation was different. This is a compound. The properties are different, and it exists because it is a bonded combination of elements. So here we see that there's matter, and one of the types of matter is called pure substances. And as we've seen, there are two types of pure substances, elements and compounds. Now, before going further, I would like you yourself to pause and try to give some definitions for these three terms, pure substances, elements, and compounds. See if you can do it. Okay, I will provide you with some information here. Pure substances are ones that can be purified to include only one type of particle. Think back to the slide of the sample of pure hydrogen, the sample of pure oxygen, or the sample of water, and in all of those there was only one kind of base particle. Now the molecules consisted of a few atoms. Let me go back to that. Okay, so each of these molecules has a couple of atoms, but this is a particle. This is a particle of water, and all of these particles of water are the same. That makes it a compound and a pure substance because this particle is the same as this particle and this particle. Moving back to where we were, there are two types of substances. I think that we have established that pretty clearly. You've got elements, which are, for the moment, we're going to define them as the things found on the periodic table, though there are many, many more complex ways to define elements. And then there are compounds, which consist of two or more elements bonded together. Again, there's a lot coming in terms of making that definition more sophisticated, but for the moment, that's good. Elements and compounds. The simplest particle of an element is called an atom, and the simplest element of a compound is called a molecule. Let's try it again. Here's another element, chlorine. It's located right there on the periodic table. Now, when I say chlorine, you might think of something that's added to pools, which is true, but pure chlorine is actually a gas. Here's a picture of a sample of chlorine atoms all together, again, in pairs. Try to ignore it for the moment. It's just a bunch of chlorine atoms, a bunch of atoms of this particular element, pure, nothing else involved. And here's what chlorine does in its pure form. Chlorine is an extremely dangerous gas, very, very poisonous. It was used as the original chemical weapon in World War I because when it reacts with any water of any kind on the skin or in the eyes or the mouth, it produces an extremely virulent acid. Chlorine gas, bad stuff. We don't have any of it at Shipley. Here's our fourth element that we'll discuss today, which is sodium. Sodium is located right there on the periodic table. A collection of sodium atoms looks a little different from all the other ones. It looks like this, a nice little block. Because sodium is, unlike the other ones, a solid. All the other things that we've looked at, hydrogen, oxygen, and chlorine, are gases, but sodium's a solid. And it looks like that in its macroscopic form. Pretty interesting stuff. And, like the others, pretty dangerous. Sodium reacts violently with pretty much anything, including water. When you put sodium in water, it does explode, and you might have an opportunity to see that at some point. Nasty stuff. Element chlorine, element sodium. React them together, and you get sodium chloride, which is that. Table salt. Not explosive, not reactive. Pretty boring, actually, because again, this is a compound made of these elements. And the properties completely change because that reaction changed everything. And we get table salt, which, yeah, can be bad for your health, but not nearly as much as eating a chunk of sodium, which would be very bad indeed. And there you have it about the type of matter that are pure substances. They include elements and compounds, and we've seen a couple of examples. But as you might guess, there's an entire other side to this diagram that's not pure substances, which would mean they are substances that cannot be purified to include only one type of particle. Another way to say that is stuff that's made of a bunch of different kinds of particles. And those things are called mixtures. To understand mixtures, let's go back to the things we made before. Here's the water we made before, a collection of water molecules. That is, this sample represents a pure compound. And here's the sodium chloride we made before. Now, when we put these two things together, they do not react together, which I think is something that we've all seen. We've all had some sort of opportunity to put sodium chloride, that is table salt, together with water, and we saw that no particular reaction happened. They just hang out together. So when you put these two together, you make salt water, a mixture. In this case, no reaction has happened. The water molecules look exactly the way they did before. Now, I know that the sodium chloride doesn't look the way it is before, that the particles came away from each other. And I'm sorry, I know that's confusing, but you just have to take my word on it that the sodium chloride is still sodium chloride. It's still salt. It's just salt that got mixed with water. But nothing fundamentally about these things has changed. The water is still water. The salt is still salt. They're just together. Another way of thinking of salt water is this. So salt water is a pretty common thing in our world. In fact, about 70% of the water on our planet comes in this form, which is seawater. Now, we all know that seawater isn't only salt and water. There's a lot of other things in it, but the idea still stands that that is a very good example of salt water, a mixture. So what we see here is that mixtures are a blend of two or more types of particles. Unlike a pure substance where you had all of one element or all of one compound, that is one type of atom or one type of molecule, here you've got two or more types of particles, and those particles may be atoms, molecules, and all sorts of different kinds of particles. Well, they're all atoms or molecules, but all different sorts of atoms or molecules. Now, there are two types of mixtures, and they are called homogeneous, also called homogeneous, and heterogeneous. Now, if you know anything about these beginnings, these prefixes, the term homo means same, and the term hetero means different. So what it means to be a homogeneous mixture means that all of it looks the same. And to be a heterogeneous mixture means the different parts look different. Homogeneous mixtures are uniform throughout. You cannot see the things that are mixed together. Heterogeneous mixtures, you can see the different types of particles. And as a reminder, we're talking blends of molecules and atoms, all different kinds. As a final example, here's another picture of that homogeneous mixture I like to talk about, seawater, and a little more calm in this picture. And as you can see, when you look at an ocean, you cannot see the salt. It's just dissolved into it. In contrast, this is a heterogeneous mixture. You can see the different parts. So there we have it, all the various kinds of matter. And basically, it's elements, compounds, and mixtures. Now, one final point. The last thing to consider is, which is the most common in the normal world? Let's think about the elements we've seen here. How many times have you seen or been around a pure sample of hydrogen gas? Probably not a lot. What about oxygen? Now, I know you breathe oxygen all the time, but that's not pure oxygen. That's oxygen mixed with something else. What about pure chlorine gas? How many times have you been around that? I hope not many, and if you were, I hope you were really, really careful. And same with sodium. You probably haven't seen any pure sodium in your life. Pure elements, in their pure form, are exceedingly rare, except maybe in a lab, but in nature, they don't happen very much. How about pure compounds? A pure sample of water or a pure sample of salt? Well, you've probably had things close to that. Maybe they had some impurities in them, but that's a little more realistic. Then what about mixtures? How many times have you come across mixtures? Water mixed with salt, water mixed with sugar, all kinds of things. And you begin to see that, yes, you've encountered mixtures all the time in your life. Because when it comes to the stuff that's actually in the world, most of it is in the form of mixtures. It's a mixed up world. But we have to understand elements and compounds because they're the parts that make up the mixtures. And that is what the bulk of this course will deal with. Thank you.